Hello guys, today you'll be learning about the inverses of functions. Here we have the quadratic equation y is equal to x squared plus 6x plus 9. Let's start off by graphing this on the graph we have over here. Okay, so we know the y-intercept is 0, 9 because the constant value c is 9. Okay, so let's plot 9 here. Okay, the 9 should go there. Yeah, okay. So then we'll solve for our vertex now. Negative 6 over 2 is equal to negative 3. Plug in negative 3 to the original equation. Y is equal to negative 3 whole squared plus 6 times negative 3 plus 9. Simplify it, y is equal to 9 minus 18 plus 9. And this whole thing is just equal to 0 now. Because 9 minus 18 is negative 9 plus 9 is 0. Okay, so then the value of our vertex is negative 3, 0. Let's plot that on the graph. That's over here. So that means our other point, since the line of symmetry is over here, another point should exist over here on the parabola. So now let's graph this. Let's draw the parabola. Okay, so our parabola will look something along the lines of this. It's not exact, but it's close. Okay, now let's find the inverse of this equation. To find the inverse of this equation, all we have to do is switch the variables. I'll show you what I mean. Here we have y is equal to x squared plus 6x plus 9. To switch the variables, all I have to do is rewrite the equation as x instead of y is equal to y instead of x squared plus 6y plus 9. The same method works on linear equations. You'll get to see that in the practice problem. Okay, so now from here, we just have to factor this part like we would a normal equation. So two numbers are 3 and 3 that add up to 6, and 3 times 3 multiplies to 9. Okay, so that means our equation will be x is equal to y plus 3 times y plus 3, or just y plus 3 whole squared. So from here, try to isolate the y as much as we can. Next line, we get x, square root of x is equal to y plus 3, and we got that from eliminating the square over here from that. And now from here, we can rewrite that as root x minus 3 is equal to y. So y is equal to root x minus 3. So that will be our inverse of y is equal to x squared plus 6x plus 9. Let's plot that on the graph now. Let's plot it in red. Okay, so the points are, so let's try to find the y-intercept first. So we set the x to 0, square root of 0 is equal to 0. So then we get y is equal to 0 minus 3. So then we get y is equal to negative 3. So our y-intercept will be 0, negative 3. And that's over here. So now let's solve for x-intercept. The x-intercept, all we have to do is put y as 0. So we can say 0 is equal to root x minus 3. 3 is equal to root x. So then 3 squared is equal to root x whole squared. So 9 is equal to x. So 9 comma 0 will be our x-intercept. Okay, same thing as before, line of symmetry comes. A point shall exist here. Okay. I drew the second half of the graph in dotted lines because technically speaking, it does not exist because that part of it is not the function. The actual function just looks like this. You can remove the dotted line. This is the actual inverse function. Because functions can't have two y values for one x value. So we only have the top one. But the bottom one's good for reference. That's why I put it in dotted lines. A cool thing about inverses, okay, so let's take this. Here's a cool thing about inverses. Let's take a few points from our first original graph. Let's take, of course, our vertex, -3, 0. Then let's take the y-intercept, 0, 9. And then let's take the other point that we said exists. It would be -6, 9. So these three exist in the original equation. A cool thing about that now is if we reverse these, which means I put them as 0, -3, 9, 0, and 9, -6. If we check, and check, all three of these exist in the inverse. So that means we can flip the coordinates of the originals and then create the coordinates of the inverse. And technically this last one here doesn't exist on the function, but it's part of it. Okay, I hope you understood that. Now let's get on to the practice questions. This topic is kind of a tricky topic, I understand. I also didn't understand it the first time when I was learning it. If you have any doubts, you can put it in the comments. I will try to respond. Okay, let's do a practice problem. For the practice problem, we'll do only one, which is we'll do a linear equation. Let's take y is equal to 4x plus, let's say, 6, or let's not do 4x, let's do 2x. Y is equal to 2x plus 6. So let's find the inverse of this. Pause the video if you want to try to solve them, or solve it. Okay, let's get into the solutions. So let's start by exchanging the variables. So you can rewrite this as x is equal to 2 times y plus 6. And then we can subtract 6 from both sides. So we get x is equal to x minus 6 is equal to 2y. And then we can divide this whole thing by 2 to get the original y. Y is equal to x minus 6, the quantity of x minus 6 over 2. So that's our new equation. We can also rewrite that as 1/2 x minus 3, but they're both the same. You know what, let's do another practice problem also. It's not erasing. Okay, there. Let's take another linear equation. Let's have number 2 y is equal to 3x minus 4. Pause the video now to try to solve this one. Okay, now I'll be going through the solution. So here, we can exchange the variables again. Oops, that. Okay. Yeah, let's leave it like that. We can exchange the variables. We can have x is equal to 3y minus 4. Now we add 4 to both sides to get rid of the constant. Now we have x plus 4 is equal to 3y. Divide this whole thing by 3. Then you get the relational y, because the 3 and 3 cancel out, y is equal to x plus 4 divided by 3. Okay, I hope you understood. Thank you. Bye.